Hi everyone. This is a problem under mechanics, forces and motion, which I would like us to look at. The problem says that two forces, 5 newtons. Forces can be expressed in a vector form with the unit vectors. It can also be represented in this format as a column matrix. So this is a vector, this is a vector. There are different ways to write vectors. It's a vector form. So two forces, 5 newtons and PQ newtons act on a particle P of mass m kilogram. The particle P of mass m kilogram. The resultant of the two forces is R. Given that R acts in a direction which is parallel to the vector 1 minus 2, show that 2p plus q plus 9 equals 0. B, given also that p equals 1 and that p moves with an acceleration of magnitude 15√5 meters per second squared, find the value of m. We are saying here, given also that p equals 1 and that p, don't get confused with the p's. In the book, it's written like this, but I've made the p for the particle to be capital P. Yeah? And the p here for the force, the vector force, as small letter p, because they are saying p, but the question is clear anyway. So now let's look at the first part of this question, which says that given that R acts in a direction which is parallel to the vector 1 minus 2, show that 2p plus q plus 9 equals 0. First and foremost, we need to find the resultant of the two vectors that are given to us. These two vectors are 2,25 p q newtons. So you have, and they say the resultant of the two forces, so that is R. You have this one, which can also be written as 2I plus 5j in a unit vector form representation. That is what you have, newtons. And you have this one here, plus, again, pi plus qj. That is R. These two vectors, the two forces represented in a vector form, we have now represented them in a unit vector form. And what else are we given? We're asked to find the mass. Act on the particle. No, not that type. Not yet. We are told that the resultant of the two forces is R, that is that one, and A, given that R acts in a direction which is parallel to the vector, correct? Parallel vector. Which is 1 minus 2, which can also be written as I minus 2j newtons. From matrix, column matrix, to the unit vector representation. We have represented this one because we are told the resultant of these two vectors that act on the particle is parallel to this other vector here, I minus 2j. This has a negative here, so it's minus. If there is nothing there, you can see we put plus, plus, plus. But once the sign is being indicated as negative, you got to reflect here on the unit vector expression. So, what does it mean when they say two vectors are parallel? If two vectors are parallel, it means one is a multiple of the other. There is a magnitude or a number that is being multiplied by the other vector. So if that is the case, we are told this vector here is parallel to this vector. But by how much? By how much is it parallel to the resultant vector? By how much? What they are saying, if this vector, let me say this whole vector here, you get like 10 newtons. And you are told this vector here, this one here, is like 3 newtons. So if they are told that these two vectors, let me say this is 2 newtons, are parallel, this is parallel to this, it means this one here must be multiplied by 5 to make it equals 10. If these two are parallel, you are told this one is parallel to this is 10, this is 2 newtons. In order to make them equal, you have to multiply this by 5, so that 5 times 2 will be 10 newtons and 10 newtons. So which means if two vectors are parallel, one is a multiple of the other. The theory is simple. So if that is the case, now let's apply this idea to this problem we have on the board. Now we know, well, these vectors here, the two vectors here, let us find the resultant vector. How do we do that? This is to bring the i's together and the j's together. So we are adding 2i plus pi. So 2 plus pi, then you have your plus here, and then again you have 5j plus qj, so which means 5 plus qj. Because they are vectors, you got to be careful with the unit vectors. You don't just add everything together. Unit vector against unit vector. That is I plus I, j plus j. This is how you match them up. So now this one is being represented in this format. We have all the i's together, the x components and the y component, the j's together. So now we are told that this vector here is parallel to the resultant vector. We are trying to say that if this is parallel to this, that's a multiple of this must be equal to this. But by how much? We don't know. So if we say by lambda, so now say lambda times I minus 2j must be equal to 2 plus pi plus 5 plus qj. If this was 10 and this is 5, so we know we have to multiply this 5 here by 2 to make it equal 10, 10. But we don't know. That's why we represent this by lambda. We don't know by how much. Now we're going to find the value of this, or we're going to get rid of this from the expression, because here they're asking us to show that this equals 0. So now, what do we have here? So you have lambda I, if you distribute lambda here, you're going to get lambda I minus 2 lambda j. This is what you get, and this is equals to still 2 plus pi plus 5 plus qj. So again, I'm using this side. You now have, because it's a unit vector, we now have lambda I must be equal to 2 plus pi. So now lambda, we ignore the i's, yeah? We don't write them. So we say lambda must be equal to this, because this is as I component, they must be the same. So lambda must be equals to 2 plus p. And again, minus 2 lambda must be equals to 5 plus q. 5 plus q. So now we have two equations. And if you can see, they ask us to show that 2p plus q plus 9 equals 0. You don't see lambda there. So we got to get rid of lambda from these two equations. How do we do that? Now, you know about simultaneous equations. When you see problems like this, you know what to do immediately. You can either do substitution or you do elimination method. I always try to go for the elimination method because from what I can see here, I have minus here, I have plus here. So and I have 2 here, there is no 2 here. So I want to multiply the top equation by minus 2. Top equation by minus 2. If this is 1, this is 2. Now I'm multiplying 1 by minus 2 throughout. So I'll be getting minus, minus 2 lambda equals, I multiply by minus 2, this will be now minus 4. So now will be, this is minus 2p. I will call this now equation 3. Then I still bring my equation 2, which is minus 2 lambda equals 5 plus q. This is still my equation 2. Yeah? So what do you do to get rid of the lambdas? Now I can subtract one from the other. If I add, it's going to be minus 4 lambda. I don't want that. But if I subtract, the minuses will cancel. So now I subtract. I'm subtracting these two. So this minus this is 0. You know, minus 2 minus minus 2 is 0. So now I'm having here minus 4 minus 5. I'm getting here minus 9. And I'm getting here minus 2 minus plus q. So even this one will be minus 2p. And then because I'm subtracting, I'm getting this minus q. Yeah? Why should I put plus? So I said minus, put plus. Minus q. I'm subtracting, the minus will affect everything. And now you have all this equals to 0. So we can see now, yeah, if everything equals to 0, so I want to multiply by minus 1. If I multiply by minus 1, 0 times minus 1 is still 0. Throughout by minus 1. So minus 1 times 9, this is going to be 9 plus 2p plus q. And then just you rearrange, your 2p comes now first, plus q plus 9 equals 0. So now this problem is solved. Part A is solved. If you don't want to do it this way, substitution method, that is complicating for you, then what do? You have lambda equals to this. So substitute for lambda in this equation here. So now lambda here, now from substitute equation 1 in 2. Now put 1 in 2. Put 1 in 2. That's what I'm doing. So now I have minus 2 lambda, which is 2 plus p equals 5 plus q. So now you get minus 4, minus 2 times 2 minus 4, minus 2p equals 5 plus q. So I want to bring everything here. So now this is going to be 5 plus q, minus 4 now comes here would be plus 4, minus 2p comes over the equality sign now would be plus 2p, and what is left here is 0. So just you arrange this one, you get now 2p plus q, 5 plus 4 plus 9. Put plus 9. Solve. Because of proof. Yeah? So A is solved. Now let's look at B. B is long, I must admit. But we shall go over it. Let me stop there. If you want to get the full version, the full video of this lesson, you follow me on YouTube, and my YouTube channel is at MKTURAY. Because this is long, you can't get the complete solution on Facebook or TikTok, but on YouTube you can get the full recording at MUNIRRMKTURAY. Thank you. So let's carry on. Now the second part says, given also that P equals 1 and that P moves with an acceleration of magnitude 15.5 meters per second, find the value of M. Find the value of M. Okay. Now we are told P is 1 and P moves an acceleration of magnitude this. We are asked to find the mass of this particle. So because they are talking here about acceleration and mass, and in fact we are under forces and motion, second law of Newton's. So this tells us the formula that is required for us to use, which is the force is equals to the mass times the acceleration of a particle. This is the formula we are going to use. So here we are given the mass, we are given the acceleration. A is given. A is 15.5 meters per second squared. F, we can say F is also given as 2p. This is F. It's given to us. But we're going to find the magnitude of F, not in this way. Then we can be able to calculate for the mass. But now we have unknowns here. We have P and Q are unknowns, but they have given us P to be 1. So we are only left with one unknown Q. Can we then find Q and then go ahead to solve the problem? I think so. Okay. So let me take this off. This is J. We are told that P is 1. So from here, P is 1 So we now have 3i let's take it from here. P is 1. So now you have lambda into I minus 2j equals now 3i, because P is 1. So 2 plus 1 is 3i plus 5 plus q j. So we'll do what we did previously. Now we equate lambda I to 3i and I minus 2j to 5 plus qj. That's what we do now. We take the I components by the I components. You have lambda I equals 3i. So the i's cancel. We don't need to do this actually. We just need to say lambda and this. So now we know lambda, this lambda here, its value now, we know is 3. Correct? Lambda is 3. But we have minus 2j lambda, again minus 2 lambda minus 2 lambda equals, you are looking at the j components, 5 plus q, plus the j component here. But we know lambda is 3 now already here. So this is minus 6 equals 5 plus q. So what is q? The 5 will go over there. So therefore, their q is minus 11. And we are told p is 1. Okay? So we got those values now. Lambda is 3, q is minus 11, p is 1. So now, what do we need to calculate? What do we need to calculate here? We're asked to find the mass. We know the acceleration. We are trying to find the force, the magnitude of the force, the resultant force. So the magnitude of the resultant force, now we know Q is minus 11. So now this force here, the magnitude of the resultant force, which is R, this one here, is now equals to 2 plus 1, which is 3i, plus 5 minus 6, because we know, sorry, 5 minus 11, we know Q is 11, so 5 minus 11, and this is minus 6j. So this is minus 6j. This is now the resultant force. To find its magnitude is the root of 3 squared plus minus 6 squared. That's the magnitude of resultant force. What did that give us? So the square root of 9, 3 times 3 is 9, plus minus 6 times minus 6 is 36. So this is square root of 9 plus this, 45. So that is the square root of 45. That's the magnitude of the resultant force, right? We are looking for, I can now erase this part here. We don't need it. Let me just get rid of it so that we can have more space to do our calculation. It's an interesting problem. So now we come to the figures now. We have force equals ma, mass times acceleration. Okay? Now the force is root 45 newtons. Root 45 newtons. The mass, we don't know. Acceleration is given to us. Mass, we don't know. But acceleration times 15 root 5. We need to find this. So what do we do? We divide both sides by 15 root 5. So now we get here root of 45 divided by 15 root 5 equals m. So what is root 45? What is root 45? If you want to reduce it in a short form, it's 9 times 5, isn't it? 9 times 5 is 45. So you're having here 9 times 5 inside here all over 15 root 5. So 9 times 5, this is 3 squared times 5, 15 root 5. And 3 squared times 5, you know, the roots of the square root and square root sign. And this now will be 3 root 5 all over 15 root 5. So the roots 5 will cancel. Now 1 all over, you have now 3 all over 15, which is 1 all over 5. So your answer is 0.2 kilogram. That's your answer. The mass of this particle is 0.2 kilogram. Thank you for watching. Bye.